Transformer is on load condition, but without R and X values of windings. This is the diagram. This can be considered as equivalent circuit. These are the vector diagrams. This is primary voltage, primary current, primary back EMF, primary turns, secondary back EMF, secondary current, and secondary voltage. In this case, the no load current I0 and corresponding working current and magnetizing current, all these are not considered. So the magnetizing current and no load current are almost considered in phase. So the transformation ratio is considered as the primary voltage to secondary voltage, secondary current to primary current, primary turns to secondary turns. Here bar is placed on the top of the K. It means here we are taking primary terms on the top side and secondary terms on the bottom side. So this is primary voltage, secondary voltage, secondary back EMF, secondary current, and primary current. All these can be represented in vector diagram. This is primary voltage and primary side back EMF, and this is secondary side back EMF E2 and secondary side voltage E2 and secondary current I2. This is primary current I1, which is vector sum of I0 and I2 dash. So these are the terms with reference to primary. These are the terms with reference to core. These are the terms with reference to secondary. So the angle between secondary terminal voltage V2 and load current I2 is phi. This phi with reference to type of the load. For example, if the load is resistive type load, then the angle between V2 and I2 is 0. That means these two voltage and currents are in phase. This is the terminal voltage V2, back EMF E2, and this is the load current I2. These two are in phase. And this is the even back EMF with reference to primary side, that is minus E1. And this is flux phi, which is in the core. No load current I0. Corresponding phase angle is phi naught. This is primary current I1. Corresponding phase angle is phi 1. I2 corresponding primary side is I2 dash, that equals to KI2. The current I1 is vector sum of I0 and I2 dash. So this is the vector diagram with reference to load equal to resistive load. This is the vector diagram with reference to load equals to inductive load. That means load current I2 lags the secondary terminal voltage V2 by angle phi 2. This is the angle phi 2 and this is the current I2. This is the voltage V2. The corresponding current on the primary side is I2 dash, that equals to KI2, and current I1 is vector sum of I0 and I2 dash and the corresponding phase angles. Similarly, when the load is capacitive load, that means load current I2 leads the terminal voltage V2 by angle phi 2. This is the angle phi 2. This is the current I2. This is the voltage V2. I2 leads the terminal voltage V2 by angle phi 2. And the corresponding current on the primary side is I2 dash. And the I1 is vector sum of I2 dash and I0. And the corresponding phase angles. So these are the vector diagrams. We must be able to draw the vector diagrams and equivalent circuits.